Alright, final example. Example 10. A ball of mass 0.3 kilogram is dropped from a height of 2 meter above a tile floor and rebounds to a height of 1.3 meter. Okay, so determine the ball speed just before and after it strikes the floor. State the type of collision between the ball and the floor. Give reason. Okay, so let's try and draw this into a let's try and draw the situation lah. Okay, so there's a ball of mass 0.3 kilogram. Okay, so mass of the ball is 0.3 kilogram, and then it is dropped from a height of 2 meter. So this is a tile floor. So this is the tile floor. Hey, what's okay, tile floor. And then the ball then rebounds. It rebounds to a height of kejap macam mana ni? Okay, so dia sampai di lantai. Lepas tu dia naik lagi balik. Up to here lah konon. Okay, let's do. So the first time they strike the floor, lepas tu dia naik balik. So dia naik up till di sini, dia naik up till 1.3 meter. Okay, after tu let this equal to height final, which is 1.3 meter. Okay, so initial pula it is 2 meter. Negative 2 meter. Why negative? Sebab the ball is being dropped. So that's why ada negative. Okay. So information we have is mass of the ball 0.3 kilogram, and then initial height being dropped at 2 meter, and then final it rebounds to a height of 1.3 meter. Okay, so why this one is positive is because this one is going up. Okay, the rebound naik pergi atas. Alright. First we have to label. Okay, this one is final lah. So initially equal to 0 because dia drop. Okay, the ball is drop, so this is ball mestilah equal to 0. And then it reached the floor, we call it VB. Tapi dia ada rebound, so I would put apostrophe. Okay, dia rebound naik pergi atas. What is the speed pun mesti kita tahu juga. Okay, so let's start. Determine the ball just before and after it strikes the floor. So in this case, we are using a combination of chapter 2 and chapter 3, which is we will be using the formula v square u square plus 2as. Okay, and this one now, this one is initial is free fall. Okay, so let's find the speed of the ball before it strike the floor, which is this one. We have to find this one. Okay, so let's do that. We can use vb square equal to ub square minus 2g as I let s equal to h initial lah. Okay, so vb is the one we are looking for. So square root of 0 minus 2, 9.81, negative 2. Okay, so you'll then get the velocity of the ball before it strikes the floor to be 6.26 meter per second. Okay, boleh? Okay, now we then have to find after they collide with the flow. After it strike the flow, meaning we have to look when it is going up, when the ball is going up. Okay, so this one again we will be using v square u square minus 2gs. Tapi this one is finally for VB. Kejap let me redo. VB square VB square, and then but this one is final. I put initial, and then this one is final, and then this one is VBI square u square minus 2gs. This one is S yang ini, where S apostrophe is equal to H final, which is 1.3 meter. Okay, so this one VB final is at this point, okay, where it stops, so it is equal to 0, maximum height there. Okay, so now we can then find the speed after it strike the floor. Ngam after it strike the floor. So this one is 0 equal to what we are looking for, minus 29.81. S apostrophe is 1.3 meter. You'll then get the velocity just right after it strike the floor to be 5.05 meter per second. Okay, so hopefully this is not too confusing. But if it does, just talk to me lah. Okay, right, so let's answer question B. State the type of collision between the ball and the floor. So the type of collision we have to determine based on looking at the kinetic energy lah. Okay, so let's find the initial kinetic energy, half mBUB square plus half mBVB square. Okay, so we are looking at the initial kinetic energy. This is 5.88 joules, and then now we can look at the final kinetic energy, which is half mB VB square plus half mB VB square. Okay, so wait oh, wrong. Okay, so initially we are looking at, we have this one is for the floor. Okay, one is for the ball, one is the speed for the floor. Okay, so the floor I would put floor is floor lah, tulis floor je, floor square. Okay, so obviously this one would directly equal to 0 lah. Okay, so now this one is the same. It's not for the ball, it's for the floor, which is 0 juga lah. Okay, so this one pula yang final ni we are using the one that we found, which is this one. Okay, so so I would just give the final answer, which is 3.83 joule. So from here we can see that the total kinetic energy, initial kinetic energy, does not equal to the total final kinetic energy. So what does that mean? This is an inelastic Okay, so the type is inelastic collision lah. Okay, so this one is your flow. This example 10 has the same concept with where is it? With this one. Okay, so we have to consider both the wall as well as the ball. Okay, so same thing goes with example 10, which we need to consider the floor as well as the ball lah. Okay, the VB here, this VB here, we will be using the yang betul-betul final, which is what we dapat, which is VB initial. Okay, which is this one. Okay, that is the after punya collision. Okay, so that is on example 10, and this is the last example for the whole chapter.